So definition of matrix. Let m and n be the positive integer. That's the dimension, meaning the size of the matrix. We say it's the order of the matrix. So we count the rows first. So what I do is, always in math, we go from left to right. So whatever you hit first, the row, that comes first. And then you put the number of columns, so that's m by n matrix. And the notation for each entry, these are called entries or elements. You can use the subscript I and j. So first number is the number of rows. You see this is 1, 1. This is 2, 1. 2 is the number of rows. And the second number is number of column. So this one will be what? Second row, second column, 2, 2. This could be maybe 6, the sixth row and second column entry. And then if it's by n, same number, then we call it square matrix, like 2 by 2, 3 by 3. And the order is the size of the matrix, okay? So let's look at an example. What is the order of the following matrices? Again, go from left to right. You hit the rows first, right? So it is 2 by 3, 3 columns. This will be what? 1 by 3. This will be 2 by 1. And the last one will be 3 by 2. Those are the orders of matrices, the size, the dimensions. And a matrix is an array of numbers. Array means one or more rows or columns. And you can use the matrix to represent the vectors. So remember the vector in component form, x, y. Now you can make it row matrix, x and y, no commas, guys, and you use the brackets. And you can also make it as a column matrix, x, y, again, no comma, just brackets. And the rule that works for the vectors applies to the matrices. So when you're adding the vectors, what did we do? We added the x's and y's together, right? So when you add x's, it's 7 minus 3. So it is 4, comma, 2 minus 5 is negative 3. Now, if it's a matrix, you add, combine the same entries. You see this is first row, first column, first row, first column. You add them together. So you get 4, second row, first column, second row, first column. So you get negative 3 when you add 2 and negative 5. So subtraction works the same way. Remember vectors, you subtract the x's together. Negative 1 minus negative 3 is plus 3. So it's negative 1 plus 3, 2, comma 2 minus negative 9 is plus 9. So you get 11. On matrix, negative 1, again, minus negative 3, which is 2. But now it's the column matrix, or column matrix. So it's 2 minus negative 9, which is 11. You put it on the second row. What about scalar? If you had a scalar in front of the vector, what do? We distributed 6 to all the entries, right? X and y. You do the same thing. So here you have 6 times 8 is 48. 6 times negative 11 was negative 66. Here, same thing. You distribute 6 to every single entries. So 48 and negative 66. Addition, subtraction, and scalar multiplication is very basic. Okay? But when you multiply by matrix, it gets harder. But here, let's go ahead and try these. So again, addition, first of all, their order must be matched. Must be matching. So it's 2 by 3. This is 2 by 3. If you're adding or subtracting, the order must be equal, must to match. This is what? 3 by 2. Then when you subtract, it has to be 3 by 2. Otherwise, it becomes not applicable. So here, when you add it, it's 1 plus 2, 3, 2 plus 3, 5, 3 plus 4, 7, 4 plus 5, 9, 5 plus 6, 11, 6 plus 7, 13. Subtraction, -1 minus 15, -16, 9 minus 1, -10, 2 minus 2, 0, -8 minus -5, -3, 0 minus -3 is 3, 12 minus -11 is plus 11, so you get 33. Okay? 23? Yeah, 23. Good. So try the next one. Who said 23? Huh? Okay. Okay, if there was one, I could give you a prize, but what about multiplication? Scalar 3. You triple every single number. So it equals to 3, 6, 9. 3 times 4, 12, 15, and 18. It's not hard, right? But when you multiply matrix by matrix, that comes a little complicated. I guess that's what we're doing tomorrow. Okay. So what about this? Is this possible to add these matrices? This is 2 by 3. This is 3 by 2. Are they matching? No. No. Because, it says why not? Because they're what? Order or different. Or you can say they have different orders. So now, given matrix A and B, go ahead and try. So here's A and B. Yeah, so C, you just multiply -2. D, you multiply 4 to A, -3 to B, and then subtract it. This is -27. Yes.